Have you ever stopped antibiotics in a febrile child because you were sure that the cultures would be negative and then they came back positive? Or maybe you admitted a child for observations in the ward just in case it was sepsis and it turned out to be nothing but a viral fever. So if the answer is yes, congratulations, then you've just experienced what we call as a type 1 or type 2 error in real life. Yes, type 1 or type 2, not diabetes, but type 1 or type 2 error in real life, even if you didn't know it at the time of doing whatever you did. So today I'm going to make these two statistical concepts super simple using real pediatric examples so you never forget them again. So as pediatricians, we make decisions every day. Do we admit this child, for example? Do we investigate for UTI? Should we start antibiotics or should we wait? Every decision comes with some risk, and that is the risk of being wrong. There's where biostatistics helps us, especially when it comes to interpreting or conducting research. So let's start with a basic concept, the concept of what we call as hypothesis testing. Now, in most studies, we start by assuming something called the null hypothesis. The word null hypothesis, we also call it H0 or H0. Now, this is the default position. Like, for example, there is no real difference between two treatments. So the null hypothesis is that there is no difference between two treatments. The alternate hypothesis is the opposite. That means that there is a difference between two treatments or two methods or two investigations. But remember, when we test these hypotheses, we never know the truth with 100% certainty. We just look at the data and then decide. And that's where we can go wrong in two specific ways. So let's break them down. First is, let's start with type 1 error. Now, type 1 error happens when we reject the null hypothesis, even though it's actually true. In simple terms, it means when there is a difference, but there really isn't. Actually, we think that there's a difference, but in fact, there is no difference. For example, let me give you a clinical example. You do a study on oral dexamethasone versus IV hydrocortisone in group, and your results say that oral dexamethasone is significantly better than IV hydrocortisone. So you switch your entire unit to oral dexamethasone. But later you realize that the result was just a fluke. There was no real difference. So you just made a type 1 error, which is a false positive. It's just like calling a urine culture positive when it was just a contaminated sample. So remember, the type 1 error is actually false positive. Just like you thought you won, but you were wrong. So remember, type 1 errors is actually creating a false positive. So that is when the null hypothesis is actually true, you make it false. So remember, you actually create a false positive. So type 1 error is that assuming there is a real difference when there is actually no difference. So that is type 1 error. Now let's move on to what we call as type 2 error. Now type 2 error is the opposite. Here you fail to reject the null hypothesis because it was actually false. So what you did, you actually missed a real difference. I will give you a clinical example. For example, you compare rectal versus oral paracetamol in febrile seizures. And then based on your data, you conclude that there is no difference. But later you actually found out that rectal paracetamol was clearly more effective than oral paracetamol. But your study had too few patients to detect it, and you probably said that there was no difference. So what actually you made was a type 2 error that is actually a false negative. Just like you have missed Kawasaki disease because you just assumed it was a viral fever. So a type 2 error is a false negative. Now remember that the way to remember or visualize these both type 1 and type 2 error is that type 1 error, the null hypothesis was actually true, but you rejected it. In type 2 error, the null hypothesis was false, but you actually accepted it. So in type 1 error, you actually created a false positive, and in type 2 error, you created a false negative. It's as simple as that. Type 1 false positive, type 2 false negative. So let's bring this back to the ward, okay? In terms of simplicity. So let's say type 1 error, you diagnosed sepsis, but it was viral and you treated unnecessarily. Type 2 error, you thought it's viral, but in fact it was sepsis, so you missed a true diagnosis. So remember, the balance actually matters in research and in practice. So you have to see whether you are more willing to make a type 1 or type 2 error. Again, in an ideal situation, whenever you are doing a clinical decision making, your chances of type 1 as well as type 2 errors should both be minimum. And having understood type 1 and type 2 error, let me give you a quick note on alpha, beta and power. These are another biostatistical terms which you might come across when you are reviewing research articles. Now, in biostatistics, we quantify these risks. So alpha is the probability of type 1 error. So whatever probability we are willing to take for making a type 1 error, that is alpha, and it's usually set as 5%. So you do not want to take a high risk and you do not want to go more than 5% for this type of error. So it's usually set at 5% or lower in high quality research. So type 1 error, the probability of type 1 error is known as alpha, and it is usually set at 5%. Now beta, the term beta is the probability of making a type 2 error, and it's usually set at around 20% or less. Okay, you shouldn't be going more than 20%. And the term power is equal to 1 minus beta. 1 minus beta, and that power means it's actually the chance that your study correctly detects a real difference. So higher the power, higher is that your study would actually correctly detect a real difference if it exists. So remember, the lower the beta is, that is the probability of type 2 error, higher would be the power of the study. So I would say that both type 1 and type 2 errors are important, but like if you take clinical relevance, then probably type 2 error has got more importance. So you should be keeping the probability of type 2 errors at its minimum. So if your study has low power, you are more likely to make a type 2 error and miss something really, really important. So this was all about type 1 and type 2 errors, and I've tried to simplify the concept of these two errors by giving you some very simple examples from the field of pediatrics. Hope you have liked it, and if you have liked it, give me a thumbs up, share and subscribe to my channel. Have a very good day. Take care and bye-bye.